Hey there! I'm back in the lab today working with the team of space engineers to figure out our next important requirement weight limits. We could use your help. In order for the rocket to actually get off the ground, we have to consider the payload of the rocket. The payload is the overall carrying capacity of the vessel, including all crew, gear, fuel, and the vessel itself. For this mission, the launch payload must be less than 110,000 pounds, plus a buffer calculated using 50% of the astronaut's weight limit. So, today, the engineers and I are trying to determine a weight limit for each of the 8 crew members to ensure a safe launch. This is the inequality the engineers came up with. 108,000 plus 8W is less than 110,000 plus zero point 0.5W. Do you notice anything different about this inequality? Yep, I see that too. This inequality has 2 variable terms. In the equations unit, we encountered this same phenomenon with equations. What did we do to solve an equation with 2 variable terms? Oh, that's right. We used inverse operations to cancel one of the variable terms and solve as usual. Okay, let's try this out with some simpler examples first before we tackle this inequality. Consider this first example. 10x is greater than 4 minus 2x. If you're feeling confident, you can pause here and try this on your own first. Otherwise, just work through this with me. So, I want to cancel one of these variable terms. Does it matter which one I choose? Nope, but in this case, I'm going to add 2x to both sides to cancel this negative 2x on the right. Why do you think I chose to cancel the 2x and not the 10x? Do you see how this 10x is the only term on the left side? If I cancel the 10x, I'll need to move the 4 over here to isolate the variable term to finish solving. But when I cancel the 2x, the 4 can stay where it is, and I just have one more step to solve this inequality, which is dividing both sides by 12. When I divide both sides by 12, I'm left with the solution x is greater than 4 over 12, which reduces to 1/3. To graph this solution on a number line, I'll make this number line using increments of 1/3. So, my open circle goes above 1/3. Since numbers are greater than 1/3 to the right, my arrow extends to the right. Pause the video and make any additional notes you'd like before you move on. Time for you to try some examples on your own. Pause the video, solve each of the following inequalities, and graph the solutions on a number line. When you're finished, come back to check your work. Let's see how you did. Example 2 has 2 variable terms, one on either side of the inequality. Did you cancel the 12h or the 5h? You can choose either one and still get to the correct solution, but I chose to cancel the 5h. I'll subtract 5h from both sides, which gives me 7h minus 4 is less than 17. Add 4 to both sides to get 7h is less than 21. And finally, divide both sides by 7 to get h is less than 3. This number line has an open circle on 3, and the arrow extends to the left. In example 3, we are dealing with decimals, which is no problem since I know you all are old pros at working with decimals. I chose to add 0.4d to both sides to get 3 is less than or equal to 2.5d minus 7. You can see, if I'd canceled 2.1d, I'd have ended up with negative 2.5d on the left, which is completely correct and not a huge deal, but I just prefer to avoid negative coefficients if I can help it. So I have 3 is less than or equal to 2.5d minus 7. I'll add 7 to both sides to get 10 is less than or equal to 2.5d. And my last step to get d by itself is to divide both sides by 2.5. 10 divided by 2.5 is 4. So 4 is less than or equal to d. Make sure you have a closed circle with the arrow point to the right. Pause the video to correct any errors before we move on. Okay, I think we're ready to tackle this inequality for the team. Pause the video here and solve this inequality for W. Let's see whether we got the same answer. I started by subtracting this 0.5W from both sides. That left me with 108,000 plus 7.5W. Next, I subtracted 108,000 from both sides to get 7.5W is less than 2,000. Finally, I divided both sides by 7.5 and got 266.6, repeating. So, if W is less than 266.6, that means the astronauts must weigh less than 266 pounds on launch day to make sure we stay within the payload requirements. We are one step closer to a successful mission. Today, we solved inequalities with 2 variable terms. You'll continue practicing these skills as you complete the online practice and the lesson activities. And remember, math is everywhere. Keep exploring.
Hey, hey.